Now dear students, next question here it is, can displacement be a zero? Yes, obviously, why not? Displacement can be zero. Yes, why not? Yes, displacement can be zero, but distance covered cannot be zero if a body is moving. Because not to forget, displacement is simply the shortest distance or the distance between the 2 points, that is the initial and the final. Means what is difference between the final and the initial point? That difference is in the length give the displacement. Suppose in a case number 1, when a body is at A and again it has traveled to B and again from B to A, that body has come back to the starting position A. At the time displacement is 0, but distance covered is the sum of entire length from A to B plus B to A, that is distance covered. So in this situation, in these cases, displacement is 0, means can be 0 for this position. Means when body is moving from one point A to B and from B to back to A. Suppose when a body is moving in a circular path, suppose let us conclude that a body has started from moving A position and again it has come to the B and again it has stopped. For these cases also displacement becomes 0, but distance covered is length of entire circumference. Even in these cases, means even though it is zigzag cases, means body is moving from A position in a zigzag motion and again it return back to the A. Means let us write here B, means A and B is same. Initial point and the final point has again resulted same position, same point, and for these cases also you can write displacement is 0, but distance covered is entire length of this total zigzag length. So displacement can be 0 under some cases, okay, means when final and starting point, means initial and the final point are the same. For that condition, at that time displacement is always 0. But distance travel or the distance covered cannot be 0 when a body is in moving condition or in a motion condition. Just you have to remember these cases and you can easily understand. Now next topic is about the uniform motion, means the types of motion regarding the ratio between time and distance. Means what is the ratio between T and D? Means for the particular time what is the distance travel? Means when a body covers equal distances in equal interval of time, remember equal distances in equal interval of time, then that body is said to be in motion. Means this body is traveling or moving in a fixed rate, fixed ratio with the D is to T. Means for a 1 second, suppose let me clarify this uniform motion, means in 1 second, for a 1 second if a body is traveling 10 meter, then for the next second again body need to travel 10 meter. Maybe 0.5 second a body need to travel with that ratio, means 5 meter. Means in 1 second 10 meter, next second again 10 meter, means a body has gone to the 20 meter ahead. But if I reduce the time, then distance also reduces, but with the equal ratios. Means it is traveling the equal distances irrespective of the equal time. Means whether if time decreases, then distance also decreases, but with the same ratio. Means this body is said to be in uniform motion. And you can collect more examples here, many examples other than this. Suppose you might have seen the moving of, means the motion of hands, means hour hand, minute hand and second hand of your wristwatch or a clock. Means for each 60 minute the hour hand moves from one earlier number to the next preceding number. Similarly, seconds, second hand. So they are traveling the equal distances in equal interval of time. Next, oscillation of pendulum. Maybe suppose it has taken the same time to reach suppose A, it is the extreme position, B is the mean position, and again C. So whatever time it takes from A to B, same time is taken from B to C, and again vice versa. You might have seen pendulum clock. The pendulum keeps on swinging. Means in the same time period, in the same time interval, it goes from one position to the next and next to the further. So you have to understand, means when a body is covering or when a body is traveling equal distances in equal interval of time, then that body is said to be in uniform motion. Lots of example, you can collect many more other than that. Now just opposite to this, non-uniform motion means when a body is not covering or when a body does not cover equal distances in equal interval time. Means sometime a body is traveling very fast and sometime a body is traveling very late or very slow. Suppose for 1 second a body is travel 10 meter, for maybe 5 second next interval it is traveling only 1 meter or maybe 2 meter, anything else. Means it is not traveling in the fixed ratio of the time and distance. For that body, that kind of moving body is said to be exhibit the non-uniform motions. The example you can write in your own way, means you might have seen moving vehicles in a highways, in a roads, maybe in a countryside, means the village sides. Sometimes that vehicles moves very fast in an accelerated mode. Sometimes it retards deceleration. Means entire journey of that vehicles was in non-uniform motion. Means it did not travel equal distances irrespective of time, whether it was short interval or maybe the long interval. Means when the running boys, sometimes he runs very fast, sometimes he slows down. Means it is having the non-uniform motion. Sometimes, take your example, yourself example. Sometimes you come from your home to school very fast. Means suppose the distance from your house to your school is 10 kilometer and sometimes you travel too early and sometimes you are very late to reach your school. Means you are exhibiting the non-uniform motion. Means you may take the particular day. Means today you have reached in a 20 minutes while coming from home to school, but you are taking 30 minutes while reaching from back to your school to houses at the home. So you are having the non-uniform motion. Means there was having the fluctuating or the fluctuation in the time and distance ratio. You can collect more examples. So you should not have any problem between the uniform and the non-uniform motion.